angles between 0 and 360 degrees. We have already defined the sine and cosine in terms of right triangles and for angles between 0 and 180 degrees. In this video, we will define them for angles between 0 and 360 degrees, that is, for a complete turn. Before you work through this video, you will need to know how to find the sine and cosine for angles between 0 and 180 degrees. If necessary, you should refer to the following video, which covers this topic. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. The unity circle, in its simplest form, is exactly what it sounds like: a circle of radius 1 unit whose center is at the origin of the Cartesian plane. The x and y axes divide the Cartesian plane into 4 quarters, called quadrants. On a coordinate system, an angle may be generated by the rotation of 2 rays that share a fixed endpoint at the origin. One ray, called the initial side of the angle, is fixed along the positive x-axis. The other ray, called the terminal side of the angle, can rotate about the center. An angle like this, with its vertex at the origin and its initial side along the positive x-axis, is said to be in standard position. The angle is measured by the amount of rotation from the initial side to the terminal side. If measured in a counterclockwise direction, the measurement is positive. If measured in a clockwise direction, the measurement is negative. Look at the intersection of the terminal side of an angle alpha and the unit circle. This intersection point has coordinates x and y. When we draw the perpendicular from P to meet the x-axis, the length x and y become the legs of a right triangle whose hypotenuse is 1. Using right-angled triangle trigonometry, we can write sine of alpha is y divided by 1, or simply sine of alpha is y, since hypotenuse is 1. Sine of the angle alpha is the vertical coordinate y of this point P. In the same way, we can write that the cosine of alpha is x divided by 1, or simply the cosine of alpha is x, since the hypotenuse is 1. The cosine of the alpha angle is the horizontal x-coordinate of this point P. Therefore, the coordinates of P can be written as P cosine of alpha, sine of alpha. Now that we know the y-coordinate corresponds to the sine of the angle and the x-coordinate corresponds to the cosine of the angle, we can find the coordinates for a point P anywhere on the unit circle. Let's see how it works. Draw a sketch of the unit circle and on it find the coordinates of point P for each given value of theta. Let's start by drawing the unit circle. Then trace out an angle of 60 degrees. You should use a protractor to do this in your notebook. Believe me, this angle really measures 60 degrees. You use your GDC to find the values of the cosine of 60 degrees and sine of 60 degrees. Cosine of 60 degrees is 0.5 and sine of 60 degrees is 0.87. Let's do the same thing we did in I-10A. Start by drawing the unit circle. Then trace out an angle of 150 degrees. Before you use your GDC to find the values of sine and cosine, you should notice that the sine value is the y-coordinate and the cosine value is the x-coordinate. Since the angle is in the second quadrant, x must be negative, implying cosine must also be negative, and the y must be positive, implying sine must also be positive. Now you use your GDC to find the values of the cosine of 150 degrees and the sine of 150 degrees. Cosine of 150 degrees is minus 0.87 because in the second quadrant, x values are always negative. And the sine of 150 degrees is 0.5. Positive. Let's do the same thing as we did before. Start by drawing the unit circle, then trace out an angle of 225 degrees. Since the angle is in the third quadrant, x is negative and y is also negative, implying that both cosine and sine are negative. You use your GDC to find the values of the cosine of 225 degrees and sine of 225 degrees. Cosine of 225 degrees is minus 0.71 and sine of 225 degrees is minus 0.71. Start by drawing the unit circle. Then trace out an angle of 330 degrees. Since the angle is in the fourth quadrant, x is positive and y is negative, implying that cosine is positive and sine is negative. Use your GDC to find the values of the cosine of 330 degrees and the sine of 330 degrees. Cosine of 330 degrees is 0.87 and the sine of 330 degrees is minus 0.5. You should notice that the sine of each trigonometric function is determined by the quadrant in which the terminal side of the angle theta lies. If you keep in mind that cosine and sine share the x and y coordinate signs, respectively, you don't need anything else to remember the signs the trig functions. The chart below summarizes the signs of the trigonometric functions for each quadrant. Maybe you are wondering, we know the y-coordinate corresponds to the sine of the angle and the x-coordinate corresponds to the cosine of the angle. But what about the tangent? Well, for the tangent, we will make an addition to the unit circle. Consider the unit circle given. We take an angle theta. The coordinates of the point P, where the ray OP intersects the circle, must be cosine of theta, sine of theta. Now we draw the line tangent to the circle at the point A, where the circle cuts the positive x-axis. Next, we extend the ray OP to meet the tangent at the point T. The length of the segment AT is the value of the tangent of the theta angle. The right triangles OMP and OAT share the angle theta, so are similar. That is, the lengths of their sides are proportional. We can write AT divided by OA is equal to MP divided by OM. Replace AT by tangent of theta, OA by 1, MP by the sine of theta and OM by the cosine of theta. The tangent of theta is equal to sine of theta divided by cosine of theta. Draw a sketch of the unit circle and find the value of the tangent for each given value of theta. Start by drawing the unit circle and the tangent line. Then trace out an angle of 40 degrees. Use your GDC to find the value of the tangent of 40 degrees. We can represent this value of tangent on the tangent line, and to do this, we just extend the terminal side of the angle to meet the tangent line. Start by drawing the unit circle and the tangent line. Then trace out an angle of 155 degrees. Use your GDC to find the value of the tangent of 155 degrees. Represent this value of tangent on the tangent line. We just extend the terminal side of the angle to meet the tangent line. Take a look at the point where the tangent line crosses the x-axis. Upwards, the values of the tangent are positive, and downwards, the values of the tangent are negative, as with the y-axis. Start by drawing the unit circle and the tangent line. Then trace out an angle of 213 degrees. Use your GDC to find the value of the tangent of 213 degrees. Represent this value of tangent on the tangent line. Extend the terminal side of the angle to meet the tangent line. Start by drawing the unit circle and the tangent line. Then trace out an angle of 310 degrees. Use your GDC to find the value of the tangent of 310 degrees. Represent this value of tangent on the tangent line. Extend the terminal side of the angle to meet the tangent line. If the terminal side of an angle lies on one of the axes, it's called a quadrantal angle. The quadrantal angle is 0, 90, 180, and 270 degrees. Pay attention to the unit circle below. Let's determine the coordinates of the points that lie on the axis, that is, the coordinates of the points in the quadrantal angles. The first quadrantal angle is 0 degrees. At this point, the x-coordinate is 1 and the y-coordinate is 0. The second quadrantal angle is 90 degrees. At this point, the x-coordinate is 0 and the y-coordinate is 1. The third quadrantal angle is 180 degrees. At this point, the x-coordinate is -1 and the y-coordinate is 0. The fourth quadrantal angle is 270 degrees. At this point, the x-coordinate is 0 and the y-coordinate is -1. We can see that the maximum value of x is 1 and the minimum value of x is -1. And this is also true of the values of y. The maximum value of y is 1 and the minimum value of y is -1. With regard to the sine and cosine values, the unit circle illustrates the following. The cosine of a quadrilateral angle is the x-coordinate, so the minimum value of cosine is -1 and the maximum value of cosine is 1. The sine of a quadrilateral angle is the y-coordinate, so the minimum value of sine is -1 and the maximum value of sine is 1. The only values that sine and cosine could have at a quadrilateral angle are 0, 1, or -1. Now let's find the values of the tangent in quadrilateral angles. The first quadrilateral angle is 0 degrees. The tangent of 0 degrees is the sine of 0 degrees divided by the cosine of 0 degrees. 0 divided by 1 is 0. Therefore, the tangent of 0 degrees is 0. The second quadrilateral angle is 90 degrees. The tangent of 90 degrees is the sine of 90 degrees divided by the cosine of 90 degrees. 1 divided by 0 does not exist. Therefore, the tangent of 90 degrees is undefined. The third quadrilateral angle is 180 degrees. The tangent of 180 degrees is the sine of 180 degrees divided by the cosine of 180 degrees. 0 divided by -1 is equal to 0. Therefore, the tangent of 180 degrees is 0. The fourth quadrilateral angle is 270 degrees. The tangent of 270 degrees is the sine of 270 degrees divided by the cosine of 270 degrees. -1 divided by 0 does not exist. Therefore, the tangent of 270 degrees is undefined.